Right, hello guys, and welcome back to another part of my DIY analog synthesizer basic tutorial. What I'm going to try and do in this video is quickly show you the Arduino Midi to CV gate sort of setup and circuit working. I've kind of skipped the schematic, I will come back to that. I just wanted to show you what's going on here. As we've seen before in the previous video, you've got the Arduino Uno. Now what we have is the MIDI. So this is going to be the digital MIDI signal going into our MIDI jack socket, our female MIDI socket, which is linked to an optocoupler, and the digital to analog converter 12-bit, which is the MCP 4921, and that's wired up to this Arduino Uno here. And we have our power supply, which goes into our reference voltage with the trimmer, which I showed you in another video. Keep your eyes on that one. Got a meter here just to measure what's going on, and also I've got the scope. I've got a scope, PC scope, which is taking the output from this audio interface here. So I've just literally just lashed up these cables here. If you see, we've just got a normal stereo jack. So one side is going into ground from this set of cables here, the ground side, and then I've linked the left and the right side to just make a mono sort of signal feed cable, which I use all the time when I'm going into digital pin number 2, as you can see there. So that's all set up now. So if I depress the key on the mini brute to transmit the MIDI, and we look on the scope and we see those pulse lines, that is our gate pulse. Now that gate pulse is what is going to be triggering our envelope generator, and that is coming from, as I've said before, that comes from our Arduino, not the DAC. So it's like a pulse. So we're setting the voltage pulse out. If we hold that longer, we can see how longer that's sending quite a longer pulse there. Now, what I'm going to do is, if we go over to pin number 8 on the DAC, and I probe into pin number 8 on the DAC. So let me just set this up a bit better to get in there. So I've gone into pin 8 with the voltmeter on the DAC, which is our voltage out. And as you can see here, this is our voltage reference, which is roughly about 5 volts. And I'm feeding that into pin 6 of the digital to analog converter, rather than trying to feed it voltage reference from the Arduino itself. So if we just take a ground out and take it to any ground input on the Arduino, should be good to go. Now, this is not 100% set up properly, but now if we just take note of the octave range, let's have a look there. I think I'm in the very bottom one, so the bottom C would be about 16.7 something hertz. Let's not get too technical anyway. So let's trigger that, and I'm getting about 0. This is the CV, note CV value, which is coming out. If we look onto, we can see that gate is still triggering as I'm pressing that, which will initiate the envelope generator contour. So you won't get a small pulse like that. It all depends on how your envelope generator contour is set up. So we just trigger that like so. I'm yet to try and improve this circuit, try and make a better reference voltage. And like I said, got a problem with this, doesn't seem to hold its CV value. I don't know why. There's a lot better sketches out there, but this is a very basic one which will kind of get you started. Like myself, I'm going to try and look into a bit more sophisticated things like pitch bend, velocity, etc, etc. If you have a synth or something, you build something which has that capability anyway. So if we go into C0, that's giving me about 0.48. I'll go to C1. Let's just make sure I'm in the right place. Let's just go up. Oh, that was mine. It was minus. It was in the minus range there. So as we can see, if we go to, I'm on about C1, I think, or C2. C1 is 0.13. Go up to the next C. So that's 0.1. That's 0.13 millivolts. And then we're at 0 volts here on this C. Go up to the next C, we're about 1.18, Next one, these values are all over the place, to be honest with you, at the moment. So we can see that we're rising up to 2.24, so every key 2.32. As I'm going up the keys, that voltage value, we can see that it's increasing. And now what we're trying to target for is a 1 volt per octave, so a space between, say, these two C's, whatever the value is, it doesn't matter exactly what it is, but it will equal 1 volt or near enough 1 volt, or 0.999 something infinite value, or even say between these two here, these two D's, it will be 1 volt, the spacing of the voltage. So we can see there, and if we look on here, we can see our Arduino. We might just be able to see that small LED light triggering as I'm triggering the key from the mini brute. As we start to go up, we can see there we've hit 4.8 up here. I've gone up the range, and there we can see that is definitely working. I'm just kind of going a bit random here with the key, so don't watch that. And we go down, and basically that's all there is to it. Like I said, in the next video I'll try and show you the schematic. It's a little bit boring. People kind of want to see things in action, but let's not try and run before we can walk. So there we have it. Like I said, again, I can try and trim that reference voltage, which I'm actually going to have a go at doing now. So I'm going to pull the voltage, the meter probe out, and then see what my reference voltage is outputting. So we've got 5.23. Going to give that little trimmer a turn. 5.88, 5.23, which is a bit high. I've swapped the trim over from 100 I had in the other day to 50, so 5.23 is the value we've got. So we could try and bring that down closer to 5 volts and then see what comes out. Anyway, you kind of get the basic idea of what's going on. So, you know, ask questions and leave comments. Don't forget to subscribe, support the channel and all that. And I'll be back with more videos, etc. Alright people, take it nice and easy. Catch you soon.